Welcome, young mathematicians. Here we want to talk about the theory behind confidence intervals. So, a really important point of notation, when we're talking about mu, that letter that looks like an M with a little drop down in front, that's the letter mu, remember, and that's the population mean. X bar is the sample mean. So, the thing about population means and population proportions is we don't know them. That's why we do inference, is so that we can take something we do know and make a statement about the true parameters. So whenever you see P, that's the population proportion, and P hat is sample proportion. Let's move on. So remember how a sampling distribution works. We have some center that's centered around the mean, and then we sample from that sampling distribution. So one sample might produce an X bar here. Another sample might produce an X bar there or an X bar there. Most of these should be close to the true average, except every once in a while we're going to have an average that's way out. And notice if we make an interval around those averages, if we make it a certain width, that most of the time we should catch the true average. So this is that plus or minus 5% that you see when you're watching the news and they're talking about a poll result. They say there's a margin of error of 4%, or say the results are within a margin of error. Well, that's what we're speaking about right here. So the one on the left has the true mean and the one on the right does not. But most of the time, if we make the sample wide enough, we should be able to catch it. So there are different levels of confidence, and what these are saying is how often you expect to catch the mean using similar methods. So a blank percent of samples catch the true average. This doesn't mean that the average is 99% of the time within that average. Let's take a look at the previous slide. Notice on this interval on the left, the mean is in there. That's not changing. But over here, it's saying 99% of the samples catch the mean. So if we were to do this again, or we were to do this 100 times, we'd expect to catch the mean 99% of the time. If you have higher confidence, that must mean that your width is higher. Right? Because if you give someone a larger range of numbers, you're more likely to be correct. So, in general, if you have 95% confidence, that means that you're looking between the middle two standard deviations of the data, which we're going to call Z star, is 2 by the 98, 90, 95, 99.7 rule. Z star tells us how many standard deviations of error. So this is the amount of error allowed. That is specifically determined by a 95% confidence. Let's take a look at an example. Let's say X bar is 3, standard deviation is 10, and the sample size is 50. If you have a 95% confidence interval, that means Z star is 2. If you have a 90% confidence interval, that means Z star is 1.68. If you have 99%, that means Z star is 2.57. For the purpose of this class, we're going to stick with 95% confidence, but just be aware that if you change the confidence level, Z star changes. So, a confidence interval is the middle, right? That first should make sense, because we're centering our interval around the data we've collected. Z star we just talked about, that's the number of standard deviations above or below. And that sigma over square root n is the sampling error. If you remember sampling distributions, that sigma over square root n is the standard deviation of a sampling distribution. And that's where this comes from. From here on out, it's plug and chug time. 3 plus or minus 2 times 10 over square root 50. That's 3 plus or minus 2.8, which means our true average means we're 95% confident. the true mean, mu, is between 0.2 and 5.8. And then we need to add context to this. So between 0.2 inches and 5.8 inches. And then also here we would need to say the true mean plant height. I know I didn't have a context for this problem, but we need to add context by the mean. And we need to add context by the data. So what about proportions? Well, same idea. We center around p hat plus or minus z star and then the standard deviation of the sampling distribution. So let's say p hat is 0.2 and n is 100. That means our confidence interval is going to be 0.2 plus or minus 2. Now we're going to say this is 95% confidence level. 0.2 times 0.8 over 100, which means our true proportion is between 0.12 and 0.28. So I could say I'm 95% confident the true proportion of teenagers who will get into a car accident this next year is between 0.12 and 0.28. Alright, the next video is going to talk about how to structure this in an answer. So both of these are critically important, that you understand the idea behind a confidence interval and also how to structure it in a response. If you have any questions about this video, make sure you seek out a classmate, and if that doesn't help, then seek out my help. Hopefully you're having a great day, and finish this strong.